Hey, college algebra. Wasn't expecting a back-to-back AMI day. That left me flustered and flabbergasted. Anywho, the show must go on. We still have math to learn. Now, I know I didn't get the next note packet out yet, but I still have all the notes for the entire unit posted on Google Classroom. And what I'm going to be doing is just kind of scraping through the 5.3 part 1 and 2. It's not that hard, and it's just as straightforward as yesterday's lesson, and we'll go through and do more examples throughout the week. Hopefully on Thursday. And we'll knock some out together. But we are on a time crunch, so show must go on. So here we're going to be learning something new, quote unquote. So firstly, let's talk about polynomial functions and their end behaviors. So end behaviors is pretty much what happens when you reach infinity. And you guys were really good at that anyway. It's like the as x approaches positive infinity, blah, blah, blah. And there's actually some rules to it too. So if your polynomial has an odd degree, so degree being the highest exponent, it's an odd number being 1, 3, 5, 7, 9, like x to the first, x to the third, x to the fifth. And you have a positive number out front, positive LC or leading coefficient. So just like a positive x squared or positive x cubed or 4x cubed that's positive, then it's going to end like boop, boop. So the John Travolta, the classic. As x approaches positive, then f of x approaches positive. As x approaches negative, f of x approaches negative. And we already knew that because that's what lines do. And lines are x to the first, those are odd, right? Now, if you got a odd degree, so still x to the fifth, but you got a negative out front in front of your x to the fifth, not just anywhere willy-nilly, but like if your highest degree is x to the fifth and you have a negative 5x to the fifth or negative 4x to the fifth, then it just flip-flops to anti-Travolta. So as x approaches negative infinity, f of x approaches positive. And as x approaches positive infinity, f of x approaches negative. Kind of already knew that. Like if you had y equals negative 3x plus 4, and it would look like that because you have negative slope. And even better, if you have an even degree and you have a positive leading coefficient, even degree being x squared, x fourth, x sixth being the highest one, you have a positive leading coefficient, it'll end like boop, boop. So we already knew that because x squared is a quadratic, isn't it? It's a parabola. You have a positive number out front, it's going to point upward. So as x approaches positive infinity, f of x approaches positive, and other way works just as well. And that works with x to the fourth, x to the sixth. They all end the same way, hence end behavior. If you have an even degree and a negative leading coefficient, it's going to look like that. It's going to be pointing downward. Speaking of which, we have our first example. So here we are. We have a even degree polynomial. It's x to the fourth, so you couldn't read it. I'm going through one of the examples from the notes. So negative x to the fourth plus 5x squared minus 4. We want to graph it. How do we even start? I didn't give you a table this time because Gina Wilson didn't give us a table. But it's not too bad, especially if you know what you're doing. And we do know what we're doing. We're smart. We've been prepping for this since day one. Kindergarten, preschool math right here. Let's go. So even degree. Well, we know what it's going to end like because it's an even degree and it's got a negative out front. So it's going to end like boop, boop. So how do we even get everything else from that? Well, let's just do let's factor, okay? So let's factor this out. So if you're to factor this out, so let's first factor a negative 1 out just to make your life easier. When you factor that negative 1 out, it just flips all your signs. And just like on the homework we just did, or hopefully you just did, we've seen something like this before, right? You just factor it normally and just pretend it's a x at first and then just throw x squared on there. Same signs, both of them are going to be minus, and two numbers multiply to get 4, add to get 5, it's 4 and 1. So we got negative 1, so we got x squared minus 4, x squared minus 1. And look at that, they're both dots. Difference of 2 squares. I love these. So now I got negative 1, x plus 2, x minus 2, and then x plus 1, x minus 1. Now, we haven't formally introduced how to solve for polynomials, but it's literally the same thing as quadratics. And you were fine at that because you just took a whole final, and I spent like a month and a half on it just doing that alone. But you're setting them equal to 0 to find your zeros. So these are finding your x-intercepts. So what can you plug in here to get 0? -2 plus 2 gives you 0. So this is x equals -2. Meaning you got an x-intercept at -2. So there you go. Same thing here. X minus 2. What can you plug in? Oh, +2. Of course you can. And that means you got an x-intercept right there. And then you got your x plus 1, x minus 1. So x equals -1 and x equals +1. So there we go. So now you got your x-intercepts. You know the end behavior. So the like on the table yesterday, as x approaches positive, where's your graph pointing? Well, it's an even, and you got a negative out front. We also can find the y-intercept pretty easily too. So just plug in 0 for x at the very beginning. So 0 plus 0 minus 4 is -4. So may as well grab that y-intercept as we're there. So now we're graphing it, making it look pretty. We know it ends like this. And you don't have to worry about bouncing on this example, but we're going to go through an example where it does bounce. And just like in preschool, you connect the dots. Look at that. Amazing. Beautiful. Now, as we finished up this first example, I guess I can ask you the first question of the day for your Google form. Now, it was a little confusing yesterday because I think somehow the Google form got messed up and the first question ended up being like multiple choice with option 1 and 2, but they're supposed to be free response, and I think I fixed it for this round. But your first question is, spend your favorite math topic you've learned in my class. Not like, oh, I love geometry because it just made sense, but we have learned a lot of math, right? And I know some of it's dry and some of it's boring, and even I don't like teaching half of it. But, you know, it is rather important. You know, scratch that. No, that's not going to be question 1. So forget about that question. If you already wrote your response, sorry. Question 1 is going to be, why do you think all math majors, or not, why do you think all college majors have to have a math class like college algebra under their belt? Because this is the bare minimum math class, really, for almost all majors. Any real degree, really. So why do you think that? That's question 1 for you. So I kind of want to know your thoughts on that. And I know, like, you might have some strong opinions, but yeah, I also do too. So I may not agree with having this class be the requirement for all degrees as well, but there is a rhyme and reason. And it's not just like, oh, it's because everybody is wrong, and you know, same thing. But let's go through one more example. So I got it kind of hand cherry picked right here, but it's going to be like kind of the next one right after that. So here we go. So x cubed minus 6x squared plus 9x. And that's going to be our next and final example for the day. Like I said, we're going to be going through it together in class, but we're going to be going through some other examples. But we do have to kind of hit this up because, you know, it's important. And I at least want to get a head start, and we can't just not have a free day because then I don't get paid. And we got a lot to cover, and I don't want to have us more time to review later on in the semester when senioritis hits hard. So there we go. Let's graph this bad boy now. X cubed minus 6x squared plus 9x. Well, just like how we graphed the other one, first let's take a look at the end behavior. It's an odd degree. So because x cubed, and it's got a positive number out front, or it's +1, right? Because there's no negative there. So you know it's going to be a classic Travolta, right? Where it's going to look like that shape at the end, toward the end behavior. So let's factor. We can factor an x out right from the get-go. So that means you got x, and then you got x squared minus 6x plus 9. It becomes a classic factoring after that. right? Same signs, both of them are minus, and two numbers multiply to get 9, add to get 6 is 3 and 3. So then you got x minus 3, x minus 3, or, very important here, x minus 3 squared. Now, that's the important part. So what does that square even do? Well, this is called the multiplicity. That's the fancy vocab term. And it's usually kind of mult is how we abbreviate it. Now that multiplicity is important when you're actually graphing these bad boys because that determines what happens at that x-intercept. And just like before, with these end behaviors, it matters if it's even or odd. Now, let's take a look at the zero. So don't think it's a shocker. We can plug in 3 to get 0. Because 3 minus 3 gives you 0. And then because you got that x hanging out front, you also have a 0 at x equals 0. Because 0 times any number gives you 0. And actually graphing it out now, well, you got your x-intercept at 0, which means that's also your y-intercept. Telling you now, because you plug in 0 for x, you got 0 plus 0 minus 0. So they're both the same on that one, since it's the origin. And then you also have your x-intercept at 3, positive 3. And we know the end behavior because it looks like a Travolta. So after the last x-intercept, it's going to go all the way up there. And we know after that last x-intercept on the other side, it's going to go like this. Now, here we connect the dots. And here it bounces at x equals 3. Because if it didn't, then it would have to go through and we'd have an extra x-intercept to account for, which you don't have. Now, if it's an even number for your multiplicity, it's going to bounce. So if that was an x minus 3 to the 4th power, 5th or 6th power, 8th power, it'll bounce off the x-intercept. But as you saw from the AMI video yesterday, and hopefully you guys were able to figure out the odd number one, so if it was a 1, 3, 5, or 7, it goes through. But the higher the multiplicity, the more it levels out. So this one just kind of bounces. But if this was an x to the 8th hypothetically, so I'll do it in a different color, then it's going to bounce, but it's going to like level off and then bounce, you know, kind of like that. Well, I'm blocking it, but it's going to bounce and then level out like that. So just a little fun fact. Now your last question, so question number 2 on your Google form is going to be, teacher is supposed to teach more than just their content, right? I'm supposed to teach more than just math. I'm a very experienced, wise old man. What would you like to learn before you graduate? Since this is primarily a senior level class, I think I only have a handful of juniors. But even then, you guys are able to answer it before. But more for geared toward the seniors is, before you guys graduate, what would you like me to teach you beyond math? In terms of like skills, like responsibility and stuff. Because when you get to college, you're going to realize that straight up the teachers here at Moberly are pretty good. And professors don't really care too much as the high school teachers do. We do quite a bit. But I do know a lot. I have lived a lot of lives, right? I know more than just a math guy. I've done a lot, and my resume is pretty built. So if you want me to teach you one thing, one valuable life skill, what would that be? That's question number 2. Anyway, if you got any questions, email me. I respond pretty quickly. Hopefully see you Thursday. Let me know if you got anything.